Hello and hi everyone. My name is Ara. We are from University Technology Mara Campus Singapore, Diploma student in Faculty of Applied Science 2005-2024. Today we're gonna explain to you guys about technology of chemistry in chemical of soap. Do you guys know how chemistry and soap is related? Let me and my groupmate explain to you guys together. Hello guys, it's me again. Today I want to explain to you guys about what is soap. Did you guys know what is soap? Soap is salt of fatty acid and sometimes other carboxylic acid used for cleaning and lubricating product as well as other applications. In a domestic setting, soap, especially toilet soap, are surfactant usually used for washing, bathing, and other types of housekeeping. In industrial setting, soap are used as a thickener, component of some lubricant, emulsifier, and catalysis. Soap are often produced by a mixing fats and oil as with a base. We continue with example of soap. We have two examples of soap. The first one is sodium laurate, which use base is from coconut oil. As we can see from the slide, the chemical formula of this base soap is CH3CH2 10COONA, and the fatty acid is CH3CH2 10COONA, which is lauric acid. The second one is sodium palmitate, which is used palm oil as a source, and the palmitic acid CH3CH214COONA for their fatty acid. There's more example of soap, which is sodium oleate, sodium lauryl sulfate, and more. Now let's move on to the next slide, which is preparation of soap. On common knowledge, soap is a cleaning agent made through a chemical process called saponification, where fats or oils react with strong alkalis such as sodium hydroxide or potassium hydroxide. Oils or fats react with concentrated alkali to produce glycerol and fatty acid salt, which is soap. Did you guys know what's happened during neutralization process? First, the fatty acids are neutralized by the alkaline solution. Then, the fatty acids are converted into carboxylate ion salt, which are ionic compounds. Next, the soap molecules are diluted in water. Last but not least, undesirable materials like phospholipid, metal ion, and color pigment are removed.
Now, I'm going to share about the history of soap making. The earliest recorded evidence of production of soap-like materials dates to around 2800 before Christ in ancient Babylon. A formula for making a soap-like substance was written on a Sumerian clay tablet around 2500 before Christ. This was produced by heating the mixture of oil and wood ash, the earliest recorded chemical reaction, and used for washing woolen clothing. The Ebers Papyrus, Egypt 1550 before Christ, indicates the ancient Egyptians used a soap-like product as a medicine and created this by combining animal fats or vegetable oil with a soda ash substance called trona. Egyptian documents mention a similar substance was used in the preparation of wool for weaving. In the region of Nabonidus, 556 until 539 before Christ, a recipe for soap-like substance consisted of uhulu or ashes, cypress or oil, and sesame or seed oil for washing the stone for the servant girls. Moving to the next part, here I will tell you about the ingredients in soap. Soap has a main ingredients and additional ingredients. The first main ingredient is oil or fat. It can be vegetable oil or animal fats, such as palm, coconut, and olive oil. The second one is lye. It's a chemical, usually sodium hydroxide, that changes the oil into soap. And the last one is water, or to be more specific, distilled water. Next is the additional ingredients. The first additional ingredient is fragrance oil. It can be essential oil or man-made oil that imitate natural scent. The second one is colorant. It can be added to change the color of the soap, and the last one is shea butter. It is a moisturizer that can improve skin elasticity. Now, I will continue with the advantages of using soap. First, it can remove bacteria since it has a hydrophobic element in it that can make dirt stick into it, and it can also break some types of bacteria and viruses. Second, it is good for the planet since the way to make it uses a lot less plastic, and it is also made with less water compared to liquid soap. Third, it is portable since it is lighter, saves space, and doesn't leak. Fourth, it can be kinder to skin because most soaps are handmade with 100% natural origin ingredients. That makes soap free from parabens and SLS. Last one is versatile. The function of soap is not only to keep hands clean, and it can since shoes, since it is most common with aromatherapy and can also loosen stuck zips. Next, I will be moving to the disadvantages of soap. Even though soap has advantages, it also has a few disadvantages. 1. Soap doesn't work well with hard water containing Ca2+ and Mg2+. 2. Soap is not suitable for washing woolen garments. 3. Soap is less effective in saline water and acidic water. 4. Soap has weaker cleansing properties than detergent.
There are types of soap such as organic soap, cleaning soap, personal soap, novelty soap, perfume soap, gas soap, beauty soap, medicated soap, glycerin soap, transparent soap, and last but not least, liquid soap. Have you guys ever wondered how does the soap works and give the cleaning effect? Let's get into it. This image illustrates the molecular structure of soap, which is the protonated form of fatty acid. A soap molecule is composed of two distinct parts, a long non-polar hydrophobic known as water-repelling hydrocarbon tails and a negatively charged polar hydrophilic known as water-attracting head. The hydrophobic tails is made up of carbon and hydrogen atoms. It is avoid water but is attracted to oils and grease. In contrast, the hydrophilic head containing a negatively charged carboxylate group negative COO negative and often associated with a sodium ion Na+. It is soluble in water. This dual nature allows soap to emulsify oils and grease in water, forming micelles that trap dirt and allow it to be washed away effectively. This shows the process of saponification, which is the best driven hydrolysis of triglyceride, fats, or oils to produce soap and glycerol. Triglycerides are composed of three fatty acid chains, R1, R2, and R3, esterified to a glycerol backbone. In the saponification process, sodium hydroxide NaOH is added, and the hydroxide ion OH negative reacts with the ester bond in the triglyceride. This reaction breaks the bond, releasing glycerol, a trihydroxy alcohol, and the sodium salt of fatty acid. The sodium salt are the soap molecules, which are amphic, meaning they have both hydrophobic and hydrophilic properties. The action of soap as an emulsifier, helping to make substances like oils and water that typically do not combine. Water can dissolve polar compounds, but oils and grease are non-polar and repel water. Soap molecules contain both a polar hydrophilic head and non-polar hydrophobic tails. The hydrophilic head dissolves in water, while the hydrophobic tails dissolve in oils or grease, creating an interface between these two. In these micelles, the hydrophobic tails surround and trap droplets, while the hydrophilic head faces upward and interacts with water. The arrangement allows oils or grease to be suspended in the water as a tiny droplets, forming an emulsion. These emulsified droplets
can rinse away, making soap an effective cleaning.
Before we end the video, let me show you guys 7 steps how to wash our hand correctly. First thing first, wet your hand with clean water and take the soap and rub it on your hand gently. Rub your palm together in a circular motion until the soap is bubbling. Next, rub back of your hand, your finger, cleanse your thumb and also tips of your finger. Rinse your hands and wrist thoroughly until all the bubbles is cleaned. Last but not least, pat dry your hands with tissue or clean hand towel. That's all from us. Bye bye!